at factoring a difference of squares. So we've done so far expanding binomials and then factoring by common factor. So this one will look at difference of squares. So this says find a pattern, expand each pair of binomials like we did in section 6.1. So we are going to expand these binomials by distributive property. So the first gets distributed to each term in the second bracket, and then the second term in the first bracket gets distributed to each term in the second set of brackets. So x times x is equal to x squared. X times negative 1 is negative x. Positive 1 times x is plus x. And positive 1 times negative 1 is negative 1. When we collect like terms, we have only one x squared. This negative x and this positive x cancel out to 0, and we are left with negative 1. We're going to do the same thing here. Distribute the first term into the second set of brackets, and then the second term into the second set of brackets. So here we're going to have x squared. X times negative 5 is negative 5x. Positive 5 times x is positive 5x. This is plus. And positive 5 times negative 5 is negative 25. So here when we collect like terms, we are going to be left with x squared. These two middle terms are going to cancel out to be 0, and we are left with that 25. So negative 5x plus 5x is equal to 0, so we can just leave that out. And lastly, we're going to distribute again. So x times x is x squared. X times positive 3 is positive 3x. Negative 3 times x is negative 3x. And negative 3 times positive 3 is negative 9. So simplifying that by collecting like terms, x squared, positive 3x minus 3x is equal to 0, and then we have a negative 9. So there's a couple things that you're going to notice here is that when you look at what we start with, we have the same x at the beginning, and we have a 1 as the second term. However, 1 is positive and 1 is negative. When we expand, we get a squared variable and a perfect square. So the square root of 1 is 1, the square root of 25 is 5, the square root of 3 is 9. But these are separated by a subtraction sign. This is the difference of squares. So let's keep going. So it says the product of two binomials, so the product, this binomial, 2 terms, times this binomial, 2 terms, share identical terms but have opposite operations of addition and subtraction, so identical x's and identical ones, but separated by addition and subtraction, is also called the difference of squares. So this is like the first example from the previous page. So let's take a look at an example here. It says write each as a power of its positive root, which means each term below is a square. Write each as a term squared. So for here, we've got 9. 9 is equal to a base 3 squared. So if we have 25 as a base 5 in brackets is 5 squared. Anytime you have a positive exponent, so anytime there is a positive exponent, it is a perfect square. So if we have x squared, that is a base of x squared. And lastly, I'm just going to write the answer here. If we square root 4, we get 2. And if we square root x squared, we get x. But we're going to keep it as a squared term. So if we look at the next page, we want to be able to recognize difference of squares just by looking at the question. So when we look for difference of squares, we need to have a squared variable. So in each of these cases, we have squared variables. The next thing we want to do is look to make sure it's a binomial. So there's 2 terms. So 2 terms, yep, 2 terms, good. 2 terms here and 2 terms here, perfect. Then if it's a difference of squares, the operation between the 2 has to be subtraction. So this is a subtraction, this is a subtraction, this is not. So this is not a difference of squares. And part D is a difference of squares. So which expressions are differences of squares? A, C, and D. Not B, it is an addition. So it is not a difference of squares. So if we are going to factor, when we factor a difference of squares, the first thing you want to do is you want to draw your 2 sets of brackets, because you know you're going to need 2 sets of brackets. The second step is square root this first term. So x squared, the square root of x squared, I'll write it in another color here for you to see. The square root of x squared is equal to x. If we ever had x to the exponent 4, the square root of x 4 is x squared. Okay, but for this, the purposes of this, I'm pretty sure we're only going to see squared exponents. So you square root the first term and put 1 in each set of brackets. Next, you square root the second term. So the square root of 25 is 5. Each bracket gets a 5. 1 gets an addition, like we saw on the first page. 1 gets a subtraction. That is how you do difference of squares. So we'll take a look at this one. So we said 2 terms, both perfect squares, separated by a subtraction sign. This is a difference of squares question. So draw your 2 set of brackets. Square root the first term. The square root of 1 is 1. If you don't know, use your calculator. So each set of brackets gets a 1. The square root of 49, x squared, is 7x. So if we square root 49, we get a 7. If we square root x squared, like we did up here, we get an x. So both brackets get a 7x. To finish this off, 1 gets an addition, 1 gets a subtraction. That is the difference of squares. So we're going to go to D. So if I square root 9m, I'm going to get 3m. And if I square root 9n, let me just put my 3m here. If I square root 9n, I'm going to get, or 9n squared, I'm going to get 3n. and then a 3n here. In order to finish, one gets a plus and one gets a minus. It doesn't matter which set of brackets gets which. It's one. It just has to be one or the other. If we look at part B, this can't be factored. So we can't factor this using difference of squares because it's plus, or it's an addition here, and we can't pull out any common factors from either of these two terms. So this is not, it cannot be factored. Can't factor. So if you have any questions with difference of squares, just let me know. But that is the lesson. I will post some practice for you guys to do on our EDSB page.